Let's take a look at this trinomial. We have 4x squared plus 12x plus 9. Now, what you can do is check if there's a GCF, but there's nothing in common between 4, 12, and 9, nor variables, because this one doesn't have an x. So you can still factor as the same as what we did in the previous section, factoring by grouping the x table, but here another technique is check if it's a perfect square. So take a look at the first term and the last term. So the first term, 4x squared, it is a perfect square. The last term, 9, also another perfect square. In addition, I notice that the middle term is positive while the last term is positive. So it may follow the first term here, the first form. So let's check. I'm going to do the square root of the first term and then the square root of the last term. So the square root of 4x squared is simply 2x. If you do the square root of the individual part, meaning just the number and then the x squared, then you simply going to get the 2 with the x and then just put it together as 2x. But you can also just square 2x, meaning this. So the square of 2x is simply 2x times 2x. That would just equal to 4x squared. So this is indeed a perfect square. Here I'm going to do the square root of 9, which is just 3. Alright, next I'm going to do the middle term, 2 times a times b. So 2 times my a value, which is 2x, times my b value, which is 3. Alright, so 2 times 2x, that's 4x, and then 4x times 3 is 12x. So this does match with the middle term. So this is indeed a perfect square. So all we gotta do is just follow this form. Since the middle term is positive and the last term is also positive, I'm just going to write my answer in this form. So my a value, which is 2x, plus, according to this form, then the b value, which is 3, put it in parentheses, and then we're going to square it. And then that's it. And then let me box our final answer. So the square of 2x plus 3. So even though we have a number in front of the x squared, as long as if it's a perfect square, then you can keep going and factor it according to these two forms. So in this next example, I have 9x squared minus 60xy plus 100y squared. So what's different compared to the last example is now that we have another variable and we also have the y squared in the last term. So you could try factoring just like using the method from the previous section, or you can check if it's a perfect square. So in order to check if it's a perfect square, take a look at the first term. The 9x squared, since the x squared with the 9, they're both perfect square, you can definitely do the square root. And then take a look at the last term. The 100 and the y squared, both of them are a perfect square, so we can also do the square root of the last term. In addition, in front of the last term is a plus, so that's good so far. And then on the middle term is a minus. So it's very similar to the second form right here, where the first term is positive, the middle term is negative, and then the last term is positive. So after identifying that this could be similar to the second form, I'm going to do the square root of the first term and the last term. Again, I'm able to do the square root because I was able to identify that the first term and the last term are perfect squares. So the square root of 9x squared is simply 3x. And then the square root of the last term, 100y squared, is just 10y. Alright. After that, I'm going to check the middle term. So the 2ab. So 2 times my a value, which is 3x, times my b value, which is 10y. Alright, 2 times 3x, that's 6x, and then 6x times 10y will be 60xy. So it does match with the middle term. So this is indeed a perfect square. So according to the sign, since the middle term is negative and the last term is positive, I'm going to follow this form for our answer. So my a value is 3x, and then minus, and then my b value is the 10y. So I'll put this in parentheses with the square, and then this is our final answer. And let me box that up. So again, what's different with this one is we had two variables, x and y, and in the last term, it had the y squared. So if the last term, even though it has a y squared, if the whole thing is a perfect square, then you can keep going and factor according to the form that you have into perfect squares.